In a prior video, I added a console-ish steering system to a small inflatable boat so that I could steer comfortably facing forward like this, instead of like this. The steering system has worked great. I'm really happy with it. But I still have to reach way back here to operate the shift lever. It's kind of a pain. I really want to shift comfortably and easily from right here. In this video, we'll design, make, and test a simple and inexpensive shift from here system. It works like this. I pull these rings to control the shift lever. I pull the forward ring to move the shift lever forward, and the aft ring to pull the shift lever back. Now it's in neutral. Forward, neutral, reverse, neutral. It's that easy. Jeff here from Nettle Reef with DIY projects to solve common problems or just make life easy, and information about the tools, gear, and other stuff that are key to these solutions. If you're new, please consider subscribing. Combined with the steer from here system, I can steer from here, shift from here, and with the tiller extension, adjust the throttle from here. This gives me most of the benefits of a console, except unlike a hard console, I can still roll the boat up for easy stowage. The steer from here system is a simple linkage. It's made from 1/8 inch cord, nothing special, some thin bungee cord, 2 D-rings, an O-ring, a double block, a single block, and an eye bolt. That's it. In this video, we'll design the shift from here system, build it, and take it out on the water for a test. I put links below for the parts and materials that I use and recommend if you want to use the same stuff for your boat. For an inflatable boat that will be disassembled for stowage, the shift from here system must be easy to install and remove with minimum tools and loose parts. The cable system is split into 2 parts that are easily connected and disconnected like so. The aft section is connected to the motor and stays with it. The forward section stays with the boat. No tools and no loose parts. Let's get into the details. We'll start with the shift lever and work our way from there. This is the shift lever on my motor. Every motor is a little different. There's 2 cables that control it. One pulls it forward, the other pulls it aft. To pull the lever back, we need a block behind the shift lever. The block is attached to the motor housing with a 1/4 inch stainless steel eye bolt. I drilled a 1/4 inch hole in the housing and with a washer on each side, secured it with a nut and a nylock nut. If your motor is under warranty, you may want to hold off on drilling holes in the housing. I've had this motor for about 15 years, so I'm not worried about that. If you're in a saltwater environment, you have a risk of galvanic corrosion. This will occur where the stainless hardware makes contact with the aluminum motor housing. To prevent corrosion, the metals must be isolated. The paint on the motor housing does provide isolation, but inside the hole that the eye bolt passes through, these aluminum and stainless steel materials are in direct contact. This is a common situation and easily managed. There are several materials that will isolate the stainless steel and the aluminum. One of them is basic caulk. It's cheap and quite effective. What works better is Tough Gel anti-corrosion paste. I've used this for years, putting stainless steel hardware and aluminum masts, and it's very effective. This is how it works. Put a little dab on the bolt where it will pass through the hole in the housing. Smear it around. Put some on the inside washer. Set it inside. Put a little bit on the outside washer. Same thing. Put it on the housing. The paste will hold it. Put the bolt through. Put the nylock nut on. Tighten it up. And there we have it. I've put a link for Tef gel below. I use blocks I had left over from who knows what. Any small stainless blocks will do. I put part numbers for the blocks I use below. This is the aft block. The cable that pulls the shift lever back is tied to the shift lever here. It runs through the aft block and then through the bottom sheave of the forward double block. The cable that pulls the shift lever forward is tied to the shift lever here and runs through the top sheave of the double block. The double block is tied to the motor handle. At the ends of the motor section cables, I made loops that quickly and easily attach to toggles on the forward boat cables. I use seasons because I like the look, and that's the kind of stuff I like to do. But there are plenty of quicker and easier ways to connect the cable sections with knots, small clips, or whatever. If you like this video, give it a big thumbs up and share it with your friends. The boat cables pass through this O-ring. This is a 1-inch O-ring. It's attached to a bungee cord so that you'll pull it in. Without that, it'd run like this. It also puts the D-rings right where I want them. These D-rings are a little bigger than they need to be. You could use other materials, but it's what I had, so I used them. And they pass up here and just loop around themselves. This bungee cord is one continuous piece of bungee cord that attaches from the D-ring through there and then back to the D-ring. I attach the bungee cords to the D-rings using simple knots, but as the bungee cord stretches, the knots will tend to work themselves loose, and of course that'll happen at the worst possible time. To prevent that, when I have the bungee cords the length that I want, I put a big glob of glue on the knot to lock it in place. That works really well. I use Gorilla Glue, but any waterproof glue will work. This is the boat cable assembly. Both shift cables are connected with bungee cord, so it's all one piece. Getting the cable lengths right takes a little fussing around, but it's no big deal. These are the dimensions for my system on an Achilles LS4. This design can easily be modified for your boat and how you want the shifting controls positioned. This is how the cables attach to the boat. Quick and easy. I normally leave them on the boat. They have no sharp edges and roll up inside the boat just fine. That completes the shift from here system. Let's throw it in the water and see how we like it. The shift from here system worked great. I'm really happy with it. This project's a success. I hope you enjoyed this video. Please give it a like, share it with your friends, and subscribe to the channel.